as well. Look, find the area. Integral. Right, just run through the answer. Dom's put up here for the benefit of anyone watching the video. Let's get the magic pen out. Right, so this is the function integrated and simplified. So minus x to the 4, 5x to the 3, half x squared plus 20x. Put the limits in. So this is when x is equal to 4. It's quite obvious when x is equal to 0 we end up with nothing, but we add that on there for completeness, and the answer is 648 square units. The only thing I would add to that is this, so we make sure we're going to square the do the negative number to the power of 4. We don't get the same mistake as I had in my results. All right? Yeah? Right. Have a look at this. The velocity of a vehicle during acceleration is defined by the function v equals 20 brackets 1 minus e to the minus t, where v is the velocity in meters per second and t is time in seconds. Determine the distance travelled by the vehicle in the first 2 seconds of travel. So, what shape is the graph here? Anyone remember what that graph might look like? 20, 1 brackets 1 minus e to the minus t. Any ideas what it looks like? Come up and draw what you think, Lewis. Any idea what shape the graph of that function would look like, Seppi? From time is equal to 0 to time is equal to a few seconds. You put your idea on, Lewis. Okay, just put Lewis next to that. Don, what do you think? You've come across it before. You've come across a graph of that function, some function like that before, in electrical science last year. You had your go, Lewis. I'll give an extra. It's not about who gets it right. The idea is if you kind of got an idea what shape the function is, you got an idea what kind of result you're going to get. The 20 is significant. So you think that's sharper. Just put Dom next to that then. Seppi, any ideas? Got to come up and put what you think on the board? 20. That's the function integrated. Yeah. And simplified. So what, Lewis, have you got 20x plus 20e to the minus x, Lewis? Each disc is dx wide and has a radius of y. Yeah, so that disc is the change in x, a small slice wide, and its radius at any point along that x-axis is y. Because the radius r is equal to y, and each disc is dx high, that might just be better if we think about that as how wide that disc is, but never mind, because the volume of that slice is its area multiplied by its thickness. Yeah. The volume of each slice is pi times y squared. Pi r squared is area of a circle, the radius being in this case y, multiplied by dx. dx is the width of the slice. Yep. So we can add the volume of the discs with infinitely small dx. We obtain the formula that the volume is pi times the integral between two limits of y squared dx. That's taken all the slices between two limits, in this case a and b, and adding them all together, where the function is y squared. And this, all we've done is integrated this function with the constant pi being taken outside. And we know we can do that, yeah? So if y is a function of x, that's the equation of the curve that's being rotated. And a and b are the limits of the area being rotated. So they're the limits of the x-axis. dx shows that the area being rotated is about the x-axis. So if we were rotating about the y-axis, we'd have dy. Okay, we're not doing examples rotated by the y-axis. We're only doing rotated by x. So, going back to our original problem, if we apply that technique to that problem, how do we go? Volume is equal to pi times the integral between b and a of y squared dx. In this case, b is equal to what? What are we? Yeah, it's 1, and a is equal to 0. They're the limits of our integration. So therefore, it's equal to pi times the integral between 1 and 0 of 3x squared dx. Yeah. How do we integrate 3x squared? How can we write that? It'll help us. What happens if I remove the brackets from 3x all squared? That becomes 9x squared. Yeah? dx. Now you can integrate it, can't you? You what? That's the function. It's the function y. Yeah? Alright? But and then that's squared because that's then the 3x squared is the area of any particular slice, isn't it? Yeah? So we got pi times, when we integrate this, we end up with 9 x cubed over 3, don't we? And that's between 0 and 1. What's that simplified? Yeah. What we got to have our calculators in here, guys? Actually, it don't matter because there's no sine or cosine function here, but no. I don't see a sine or a cosine function, do you? What have I done wrong there? I don't know. 3 times 3 cubed. Oh, it's 1. Yeah. Three pi, so about 9 point something if you evaluate it. 9.3 something. Yeah. Okay. That's what we need to do. It's the integral between 4 and 1 of pi times y squared dx. That's equal to pi times the integral between 4 and 1 of x squared plus 4 squared dx. What have you done from there, those of you that had a go at it? What method have we got from carrying on from there? Yep, so the brackets multiplied out. Pi, 4 and 1, and the brackets multiplied out, Jake, are? Plus everyone agree with that? Yeah. So we end up with pi times integrate this, x to the 5 over 5 plus 8x cubed over 3 plus 16x between 1 and 4. Everyone agree with that so far? Yeah? Or not? A or nay? So it's pi times 4 to the 5 over 5 plus 8 times 4 to the 3 over 3 plus 16 times 4. Take away I have to put it underneath 1 to the 5 over 5 plus 8 times 1 to the 3 over 3 plus 16. Close brackets. And then I've got pi times 204.8 plus 170.67 plus 64. That's the first bracket. Take away 0.2 plus 2.67 plus 16. And the final answer, not evaluating pi, is 420.6 pi cubic units. Please check, because, you know, as you're all aware, I've been known to get things wrong. But that, you reckon that's right, yeah? What is it if you evaluate pi then? Yeah. It's going to be 3.1 times that, roughly. Okay, but there you see the value in taking pi outside of the integral, and if you and only evaluating it at the end, because ultimately, if you had units for y in if you had units in meters, you're going to want to know how many meters cubed it is, not 420 pi meters cubed. So eventually you're going to evaluate pi, but don't do it until the end. Otherwise, you're going to keep rounding as you go through your calculation. Alright? And here, it's easy to take it outside and multiply by pi afterwards. Alright? In your notes, there's another one to have a go at there, which you can make a start on now. I'll give you the final answer I've got for that. Here you've got 1118.2 units cubed. So that's after you've evaluated pi, that is. And then the other examples in your notes, they're straight out of the Bird book, and you've got the final answers there anyway. So have a go. Practice some of them examples. Which one's that, Dom? This one? 420.6 pi cubic units. I didn't. What you've got here is exactly what was in the exam last time. So no. Yeah? It's about knowing the method, Jake, isn't it? That you're talking about that a revolved slice through there, and you're going to get the volume of one and integrate to get the volume of all the slices. All right?